You want these? Quickly, again, a reminder, this is my last week. So I have these little, you don't have to fill these out for me, but I would greatly appreciate it, just as a little exit ticket for myself. Tell me what I did well, what you liked, what I didn't do well, any parting words or advice you have for me. It's been great getting to know you guys. I've loved my time here. I don't want to leave, so that would be very helpful to me if you fill one of those out. I'll just have them on the back desk all week. Yes, phase shifts. So we are again starting with our equation that looks a little bit different. Our y equals a sine, where b, we'll get into these actually in a second. Another word for our phase shift is our horizontal shift. So instead of going up and down, this is going to move our graph left and right. And if we remember our positive and negative, we're moving left and right. It's going to be the opposite of our vertical shift. So when we were going up, it was a positive, and down, it was a negative. But this time, if it's a negative, we'll be going to the right, and a positive will be taking us to the left. So here is going to be our general equation now. Some of the letters look a little bit different. Y equals a times sine of b times x minus c, all plus d. So what does my a value represent? And my amplitude. It's still my amplitude. My b is now frequency. It's still our frequency. So whatever number is in front of that x, that's still going to be our frequency. We can label these for ourselves. Our x is just our theta. So it can be an x or theta or any variable there. Our c, if we remember our just general functions, when it's inside the parentheses, that's going to be our, we're moving. Which ways are we moving if it's inside the parentheses? Left and right. So this will be our phase or horizontal shift. And this plus d is still my vertical shift, or my midline. So again, my plus was up, my minus was down, but now my plus is left and my minus is right, so those are just going to be switched. So our easiest way to determine the horizontal shift is how many units the starting point has moved to the left or right. We'll get there. So we always want to see where our starting point is. When we're talking about our sine curve, what are we always in reference to? We're always oscillating between that midline. So our 0, if you remember our 0 max, 0 min, 0, we're always going to look at where we're starting from for our sine curve, or our 0. Determine where we're, what? Usually yes, but now we have our vertical shift up and down, so it can change. So wherever our midline is for our sine curve, that's where we're going to be looking to figure out where we're shifting left and right from. For our cosine curve, we're going to be looking at our maximum. I'd say maximum because that's generally where we start from. I guess minimum would work too, but I'd say 7 times out of 10 looking at your max. So that's just to determine where we're shifting from, is that's where we're going to be looking and referencing from. Is either our, in quote, 0 or our midline, or a maximum. Again, just to remind ourselves of what our curves should look like. So when we want to see that phase shift, we're going to be starting from that 0 and seeing how much is moving left or right. Or for our cosine curve, looking at that maximum value here, seeing what's shifting left and right. Is it like weirdly blurry? this issue yesterday too. I might have to deal with it. Okay. So let's get into it. It just wants to identify the phase shift, so we don't need to graph anything here. It just gives us our general equation. Y equals -2 sine of 3 of x minus pi minus 6, all plus 8. So there's a few easy things we can identify right off the bat. What's my amplitude here? What is my frequency? And then what is my period? Yes. Or 2 pi over 3. What's my vertical shift? 8. What is my maximum? And my minimum?
6.
Yes. Okay, so based on what it told me up here with all my definitions, what is my phase shift? Which direction I'm going to the right. That minus tells me I'm going to the right. I'm going to the opposite of where I think it would be going. So I'm going to the right. Because like x is negative to the left, right, and positive to the right. So I'm always going to be doing the opposite of that. Our horizontal shift is always the opposite of what it's telling me. So I'm going to the right, pi over 6. And that's all it needs from me.
You have to write down like with the amplitude and frequency and all that stuff.
No, it just asked for that phase shift. I just wanted to quickly review getting those. So we got those in the same process as we did as before. Everything stayed the same as it was from Friday. We're just adding on that phase shift there. So number 2, y equals -1/2 cosine of 2x plus pi over 4 plus 10. So if we look at the difference between these two functions, there's an extra set of parentheses in this one than there's this one. So to be able to identify my phase shift, getting back to up here, my coefficient of x always must equal 1. So in this case, I have a 2 in front of my x, but in the previous one, there was a 1 right in front of that x. That 3 was outside of it. So I always need to be in this form up here to identify my phase shift correctly. So if I want to pull out a 2 from this whole thing, what am I dividing this 2x by? Or multiplying this 2x by to get this 2 out of this x?
1/2.
I'm multiplying this by 1/2, right? So I can get y equals -1/2, just copying. Pulling out my 2. If I multiply 2x by 1/2, I just get x. So if I'm multiplying this by 1/2, I also have to multiply this by 1/2 as well.
What does 1/2 just give you equal to? You take the 2 out of the
So I just copied the -1/2 cosine. I just copied this down. But I need this x to have a 1 in front of it. I need to get rid of this 2, so I multiply 2x. No. I need this x plus whatever to be all by itself. If we look at my form up here, I have this frequency out front, and then again in the second set of parentheses, I have my x minus whatever my phase shift is. I need this x plus or x minus whatever to be all by itself. That's why I'm pulling this 2 out. So if I multiply this by 1/2 to get rid of that 2, I also multiply this by 1/2. So pi over 4 times 1/2 will get me, multiplying across, I get pi over 8. And then just copying down plus 10. So this matches my form, down here. This matches my form that's all the way up here. My amplitude, my function, my frequency, my x plus or minus, my phase shift, and then my vertical shift. So I always need to get back into this form to be able to accurately get the data that I need. And just double checking my work, if I distribute this 2, I still get 2x plus 2 pi over 8, which would just get me pi over 4. So this is my phase shift here. So what is my phase shift for this equation? I'm going left pi over 8. Doing the opposite of what it tells me. What do you mean disappear? I took that 2 out. So that meant I was dividing by 2 to get that out of there. 2 times 1/2 just gets me that x. If I redistribute this 2, I would get 2x plus pi over 4. I'm not adding or subtracting anything. I'm getting it into the correct form. These two are equal to each other. 2 times 1/2 will get me 1, so that would be this 1 in front of this x. 2 or pi over 4 times 1/2 gives me that pi over 8. So if I redistribute that 2, that will give me 2x plus pi over 4, which gets me back to what the equation was originally.
Explain the way which is ways or whatever that was.
Moving on to number 3, y equals -5 sine of 3x plus pi over 2 minus 4. Am I in the right form yet?
Nope.
So what do I have to do?
Take out that 3.
Take out that 3. I leave everything in front of it alone. -5 sine, taking out that 3, or dividing everything by 3, or multiplying by 1/3. Give me x plus pi over 6. And then putting that minus 4 back on at the end. So my phase shift, which direction am I going? I'm going left pi over 6. Okay? We need to get into this form here, and then we can determine what our phase shift is. Number 4 gives us a graph of an equation. I'll just label these axes for you here. I have pi over 6, 2 pi over 6, and so on. It's kind of blurry to see there. Okay, so now there's another extra step I need to make my equation. But we're going to start our process as normal, same as our vertical shift. Where's my midline? 0, right? I'm not moving up or down at all. So then what is my amplitude? 2. I'm going 2 above and below that midline there. So now is the tricky part, getting my period or my frequency. So in this case, we can easily see how much we're moving. But in general, if we want to figure out that phase shift, we're going to start by finding our period. So where does my cycle end in this case? It ends at 5 pi over 6. And where does it start? Pi over 6. So I'm just subtracting that pi over 6 from the 5 pi over 6 to see how long my period is, which will give me 4 pi over 6. So now to find my frequency, what do I set this equal to? If this is already my period, 2 pi over f, and then I solve for that f there. So I should get 4 pi f equals 12 pi. So I have a frequency of divide 12 pi by 4 pi, I get just 3. So then, what kind of function do we have here? Which function? So this is my sine curve. I'm starting on my midline and ending on my midline. We usually start at 0, right? So how much was my phase shift? It was which direction? Right. My phase shift is right pi over 6. So now I can make my equation. I have everything I need. Y equals, what comes first? 2, my amplitude. I'm going to my max first, so it's just a positive. This is my sine function. What comes next? My frequency of 3. Then I have another parentheses. Then I have x minus my pi over 6. And then you can either leave it off or add a plus 0 if you want to. That's up to you. Do you understand what's happening? Not too bad? Okay. So the homework is really long, so we're going to start it now. We have a lot of time, obviously. I'd say just get cracking at these. I think you can just, that's up to Mrs. Hill. Write in the book or on a separate sheet?
Right in the book for now.
So number 1 is pretty straightforward. A phase shift is another saying of what kind of shift? A horizontal shift. Number 2 asks you just to identify the phase shift and in which direction. Number 3 gives you that function that you need to change to make sure you get your accurate phase shift. 4 wants you to identify both the phase shift and vertical shifts. And then I think we'll stop there for now. So just 1 through 5 or 4. Feel free to compare with your partner once you get through several of these.
Can we do number 3?
We'll walk through all of them. Just remember they have to be in the right form.
Yeah.
You might need to factor out that number up front. Okay, starting at Merrick, we're going to snake around the room. Starting at Merrick, going to Natalie, and then around.
Am I starting at 2A?
Number 2A, yes please.
Right eye.
We are going right pi. Beautiful, Natalie. We're going left pi.
Left eye over 6.
Left pi over 6.
Left eye over 4.
Left pi over 4. Back to Rowan.
We were sorry. I was distracted.
2E. Right pi over 3.
Right 5.
Right 5, thank you. Okay, for 3A, first tell me what our function should look like.
Y equals the sine of parentheses 2 parentheses x plus pi.
Okay, so then Morgan, what's my shift?
Left pi over 3.
Left pi over 2. Okay, keep on going. What's my new function?
Y equals cosine parentheses 2 parentheses x plus pi over 4.
Perfect. Okay, then what's my shift? Katya. For B, 3B. Just my shift.
Left
Mm-hmm.
pi over
Close. So we got it in this new form. So now based on this new form, what is my shift?
2
Pi over 4. We need that a 1 in front of that x inside that parentheses. Okay, Miles, you're next. What's my new function?
Y equals sine parentheses 3 parentheses x minus pi over 2.
Pi over... What did you say, pi over? Not quite. So when I factor this 3, or if I'm finding the GCF, I'm multiplying this 3 by 1/3, so then I'd have to multiply my pi over 6 by 1/3 as well. So what would I end up with? Pi over, what's 3 times 6?
Oh,
18. So then Grady, what's my shift?
right pi over
Pi over 18. We all agree with these so far? Beautiful. Who's next? Rohan. What's my shifts going on here? Up 2. That's all that's happening in this one. Yep. Left 2, yes.
right 3.
Not quite. This x, sine of x, there's a parentheses around these x, right? That minus 3 is outside of that function. There's an invisible parentheses around that x. Down 3. My shifts are always inside that parentheses. Okay, part D. Left pi over 6 and down 4. Beautiful. I think Dree is up next. 4E. 4. Up 1. That looks good to me. And then F. Left 6. Down 2. And that worked out very nicely. Perfect. Okay, I think you have 5 you can do. You find amplitude, frequency, period, phase shift, and vertical shift. 6 I think you can do as well. I want to talk about page. Let's look at question 8. Below is y equals 2 sine of x plus 4 over the domain negative 2 pi to 2 pi. Carefully sketch y equals 2 sine of x minus pi over 2 plus 4. So, it already shows us this function here. We already have our 2 sine, so our standard sine function, and then our vertical shift up 4. What's the difference between these two equations? What are we adding on for the second equation? So I already have this vertical shift, I think. So just my horizontal shift, or my phase shift, which is right pi over 2. So if this is all going by pi over 2, pi, 3 pi over 2, 2 pi, an easy way that I can just do this is I can pay attention to where I know those values are and just shift it right pi over 2. So if at pi over 2 I'm at 6, I shifted to the right pi over 2, I'm still at 6, I just shifted to the right. 3 pi over 2, I'm at a minimum of 2, I'm just going to shift that to the right pi over 2. I can also look at my zeros or my midline. My midline is now at, what's 4, y equals 4. I can draw that in for myself here. If I hit 4 at pi, I'm just going to shift that right. At 0 I hit 4, shifting it right, just pi over 2. Shifting everything right, pi over 2. I can easily just trace out my function. Okay. I just looked at my points here, saw the points I knew, just shifted it right, pi over 2. Okay, so we know we have our competition on Friday, our Pi Day competition. So every day I think I want to try to prepare for that, because I want to prove my professor proud. I want to win us this wrestling belt. Have you guys ever played Smadness before? Smadness? So I'd say group 2 or 4. Excited here, pairs. This is not based on trade whatsoever. And then one of the partners get a scrap piece of paper.
I'll be your partner.
Yeah, you go for it.
Let's go, Merrick.
So basically,
Scrap paper.
what I'm going to be
Let's
doing
go.
is creating number sentences. So I'm going to roll my die. It's going to give me 2 numbers, obviously. I need to use those 2 numbers to create one of these numbers. So let's say I have a 5 and a 4. I can do 5 minus 4 to give me 1. Let's say I have 2 and a 2. 2 times 2 is 4, or 2 plus 2 is 4. You can get very creative. You can use logs, you can use exponents. Today's the easy round. On Friday, we're going to be doing the digits of pi with 4 dice. So we'll get there when we get there. That's why we're going to be practicing today.
Do the exponents have to be one of the dice?
It has to be a number. You have to use every single number that shows up on your dice to create each of these 5 numbers. You don't have to go in the order. If you find a solution with the dice you have, you can skip to that number. You can create each of these numbers with some sort of number sentence with the 2 numbers you get on your dice. You roll for each one.
What if there's like no?
If there's no solution, roll again.
Okay.
How long do you think I should give?
Only 2 minutes left, so
2 minutes?
go for it.
Just go for it. Just go for it now. I won't time you this time. Roll those dice. Make a number.
We have dice. Go.
Think of some way to combine those
And
numbers.
3 plus 1.
Addition,
And 3 minus 1.
multiplication, division, logarithms, exponents. None of them work. And then you can roll again. Okay. You did it? Can you use the name of the place?
That was way too big. We need more dice or something. Bingo. It's madness. Did you get all 5? Yeah. Well, we're gonna have more dice as it goes, so to get it more creative. What's that? Should it be the digits at the top? Like 3, 1, 4, 1, 5, 9. I don't know how far it's gonna go. But we'll have more dice.
So you get the gist of the game, so we'll get better and better at recording. Homework is the rest of those 3 pages. The homework is the rest of those 3 pages.
Take your dice.
What's that? Careful. Yes, I do. I love it there, yeah. What do you want to go for? That's a good school to go there for. I have a lot of friends in illustration and they absolutely love it there. It's a smaller school, so everything's pretty walkable. There's like a downtown area as well. There's about 5,000 students there these days. About 1,000 students per year. What else do I know about it? Student school, so tuition's pretty nice. Food is okay. It's okay. Yes, there's a ton of spots. There's we just got a Popeyes actually, a KFC, we have a pizza, McDonald's, we have Subway, we have a couple sandwich shops, a couple Mexican places, we have a sushi place. And it's like 10 minutes from campus, like a walk, 10-15-minute walk from campus, so it's not far at all. There's a creek, there's a pier with like people will go there like on warm days for the beach and stuff. Yeah, it's really nice. I love it. I would definitely. If you want more questions, we can talk like Of course.
No, you.
Right, you're doing the same thing. You did average rate being equal.
Turn into a big zip guy? A little bit.
I don't think there's a name where he has.
No, I think I've seen it like twice.
You like juice Bill? Juice Bill?
Yeah, I sure did.
You use Bill?
I can go with ya.
I don't think it's this test.
I'm gonna be so far behind. Is the test hard? Yeah, the last year? Yeah, I got a 7. So I'm done for. I'm so excited. If you actually understand it, you probably get it. I think I did, but I don't know if I do. I don't know, I guess I'm like 7 of the questions. I didn't really have a lot of time. Going to Cambridge.
Okay.
No, my friends went there to the university. And they got me switched.
In that case, though, that'd be awesome.
Right.
Yeah.
I'll double check.
I wish I was going to I'm pretty sure it's like one of the best. It's like the Harvard of the UK. That's Oxford. That might be Oxford. It's like a,
Hey, did someone come back yesterday looking for a water bottle?
No. Yesterday. Nobody was here yesterday.
I inadvertently stole from them. Well, I didn't. They were gone, and I took it to like look for them in the lobby because it was all the way at the other side of the gym.
oh, okay.
And I knew the people behind me that were sitting there were from the other squad. Wow, it's cold in here.
Yeah, it's freezing in here.
Big old bear.
And then I saw you find 3, Fab 3 and I got distracted, although they weren't there anyway, and then I just ended up walking out holding the thing.
Oh, no.
But it belongs to someone from, God, where were they from? Far away.
What belongs to you now?
You know you-
Where is our park?
Our park? Buffalo?
No. North. Lewiston. Is that right?
My grandparents used to live there.
Lewiston, I think, is where they're from. So
About
I
an
don't
hour
think
away.
she's ever getting her water bottle
Oh,
back.
yeah.
Unless we play them again. in
Roughly.
the game.
Give or take.
I can remember.
Give or take, I don't know, a couple hours. It could be anywhere.
It's freezing, yeah?
SAT.
Yeah, okay. I
Did you
put my
take it?
coat back on and shut this.
Math was
I'm gonna go 1, 2, 3, 4, 5.
I was gonna say, I heard it.
But isn't that a good thing? Like, the harder it is, the more you're getting right. Like, isn't that how it goes?
Yeah.
That's what.
Oh, we're recording.
Oh, goody.
No,
No, you.
What,
And you think?
No.